So this is Bonsai, which just to double check, it should be already the version 2.6. Yes. And so for those of you who haven't used BondVision before, so I will assume for now that everybody has kind of seen or played a bit with Bonsai. And I'll just highlight the pieces here and there. Hopefully it should all make sense. If it does not, we can stop for a bit and go over what is going on. But essentially the starting point for BondVision is a node, a source node called create window, which is here, which you can also just type in the toolbox, create window. So if you drop that into the workflow, then you have a OpenGL kind of shader window that is rendering at the refresh rate that you specify here on the right. And there's like there are various properties you can set. But for now, this is going to be our starting point. You can change the clear color, so you can make it gray, for example. And so we'll have like a gray little starting window. Yeah, you can make it a full screen. You can make it full screen and on the showing on different displays. If you want like a full screen window and a secondary display, you can do that. So, but for now, let's keep it like this. Then to get started with BondVision, then BondVision is basically a package that on top of, so the Bonsai shaders is a package that gives you very low level access to the GPU for drawing on the screen. So it's kind of quite low level. It's very powerful in the sense that you can write whatever you want. You can write your own engine if you want on top of it, but yeah, it's very low level. So BondVision is basically the goal was to make a kind of higher level interface on top of this. So basically it brings its own programs pre-made for shaders. And the way you load these programs is there's this node called BondVision resources. So essentially so the window, this source creates a window and it gives you the window. So the output of it is a shader window that has a bunch of properties. On top of this window, you can add these resources, which are going to be either programs for the GPU or 3D models that you want to load or images or videos, any resources that you want. But usually we start for BondVision with this node BondVision resources that essentially preloads a lot of the programs that you start with. So we will add more after this, but essentially after you have a chain of these resources you want to add, you can just type load resources. And so this node will load all the resources that you want for your scene. So then there's two sources you need. One is render frame will essentially signal an event every time there's a new frame to be drawn. And you also have update frame that will signal an event every time the state of the scene needs to be updated. Like if you're animating something, everything will go for update frame. If you're drawing the current state of the world, everything is going for render frame. So I will start with, so there's lots you can do with render frame. Essentially after this, you can decide whether your scene is 2D or 3D. And you can also take into account the calibration of the screens in the environment around you, which I don't know if we'll get to that today, but we can also do that and discuss it in future sessions. For now, for prototyping, we use for 2D scenes, we use this normalized view. Is also a node from BondVision that essentially gives you a kind of normalized view where it's normalized set of coordinates where the center of the screen is coordinate 0, 0. It's for 2D scenes. And the left side in X and bottom in Y, those are coordinates -1, and on the other end you have 1. So it goes from -1 to 1 on left to right and -1 to 1 bottom to top. And on top of this view, you can then draw whatever you want. So for example, for looming stimulus, we would start with so then you have a lot of these draw primitives that if you look for them, yeah, all of these draw here, say BondVision, are all the, another option that you can find them is you can look for, I think if you go to Bond Vision. So you can go through this menu, workflow. You have collections, environment, logging in primitives. If you go to primitives, you have all of them here. So we can draw, for example, a circle. And if I do that, then I have a little circle on the screen. And now we can, I'm going to actually put it to the side so we can play with the parameters. So now what I can do is I can, for example, change the diameter of the circle or change its position as well. So now it's just drawing it with whatever parameters are in here. But as with other bonsai nodes, you can take the properties of the node. So let's say the diameter, okay, and you can animate them by giving them values that come from somewhere else. So for example, what we can do now is we can take the mouse movements, and there's two mouse moves. So the bottom one, Windows input, gives you the global, as in your desktop coordinates. The mouse move in the shaders gives you the position of the mouse just on the shaders window, so that you can have the coordinates relative to that window. Now, if we take that one and there's a convenience node to kind of normalize, to make the position of the mouse be independent of the pixels, because by default it will give you the pixel coordinates. But if you want it to give you the normalized coordinates from -1 to 1, -1 to 1, you can use this normalized device coordinates to give you those. And then what I can say is, let's say I can take the X coordinate of that and map it to the diameter. And that'll be a bit weird because there will be negative values in there, but let's see what happens. But essentially, as I move the mouse, I guess it goes the other way around, yeah, because there's a quadratic. The way the circle works, the program that is drawing the circle computes the size of it by calculating with the radius, the distance from each pixel to the center. And that is a quadratic equation. So it doesn't really matter if you're passing a negative radius. It will, I guess, have the same effect because you're just calculating, you're just looking at the length of that. Yeah, so so we have like a little circle that is animated now by the mouse. But the same way we could have it be animating something else. So we could have, we could change, so we can go to these properties, and also you can just, if you double click on them, you can change which property you want to map. That's another way to do the mapping. So we can say, now I want to control the position, so location X. And now as I move, so now it goes with the mouse. And then the X position. And what I can do then is I can say, oh, actually, I want to map both. So you can either double click and add another property, or you could externalize it from here. Both work. Now, in this case, because I just mapped it to both X and Y, what is going on is actually now moving the diagonal, because I'm mapping the same value to both X and Y. So it's going to move around the diagonal. Otherwise, we can just take, but if I want both X and Y, then what I have to do is I will actually delete this, taking the X here. And now I need to specify that I want to map the different values of the location X and Y to this input that is arriving, that now is a vector 2. So it doesn't know automatically how to do that, so we have to tell it. So we have to say, okay, for location X, we want to take the X coordinate of the vector, and for location Y, we want to take the Y coordinate of the vector. And if we do that, then it's happy again, and now we can control the position of the circle given the position of the mouse. Now what we can do is, so now this is just feeding back a live source into the property, but we can also animate it using a different, using some kind of predefined animation sequence. And Bond Vision also gives you nice operators to do that quite easily for simple animations like linear animations. So what I will do now, I will disconnect this and delete this for now. And I just want to control, I'm going to go back to the diameter control. I'll put the location back to 0, 0. And what I will do now is I will animate it. There's a node in Bond Vision, a source called the range animation, that essentially what it will do, if you place it, you can specify 2 values. This is a simple linear animation. You specify 2 values and a duration, let's say a second. And so what this will do is over the course of that second will generate the intermediate steps depending on your update frame rate that are necessary to kind of bring the value from the min to the max. So it will generate the intermediate values for each frame. You can put as many of these as you want. For now, we'll just control the diameter. And I will make it go from 0 to 1. So if I do that, then I'll have this expanding kind of circle that now doesn't do anything else other than when I start it, it just expands from the middle. Of course, we can, as I was saying, you can put many of these. So you could put another one if you wanted to control, let's say, the position of the circle. So you could do this again from -1 to 1 now, again, the range animation. And now I want to combine it with, so I want to control the location X and the location Y. So I externalize those. And I want to now animate those with the range animation that I made. And if I do that, then now I have this kind of moving and looming stimulus that goes like that. Now, if in this case, the yeah.
After range animation on diameter, for example, can we add an exponential?
Oh, yes, yeah. After which one? Any of them?
Before diameter, so it's kind of got an exponential expansion profile rather than a linear expansion profile.
Yeah. So there's this nice package that we will discuss as well that I am recommending right now. So there's this numerics package that is also a dependency installed by Bond Vision automatically. It gives you a lot of these kind of basic mathematical operations. And one of them, is exponential. We have logarithms as well. Sines, cosines, and so on. And also there's distributions as well that we'll go over in a bit. But so in using this, you can put an exponential here. So that'll be e raised to the power of this, or you can also use custom power. I think it's somewhere, I think. Yeah, but if you do that, then it depends on the scale. We may have to rescale this value over here. So that's another thing we can do that is very useful, is you can take the nodes and you can rescale them. So by rescale, of course, in this case, we can just change the animation, right? So we now, instead of going from 0 to 1, we know it's an exponent, so we can kind of change it directly. But you could also do it after, and essentially rescale would allow you to take the input range, let's say from 0 to 1, and convert it to an output range that could be different in a different way, and that will basically transform the input value into a different scale. The same could be done for the location. So that, okay, now I guess it starts from a different position, not from -1 anymore. But so you can do these kind of mathematical operations. You can also do just a simple sine or cosine. Okay. Sorry about that. There was someone ringing. I think it was the building. Yeah. Okay. Now, if we want so what is happening now is that we have essentially a circle that is moving that goes and just stops. So the animation at some point stops. So the question is then, how could we probably would be interested in controlling both the beginning and the end of this animation so that it doesn't just start right away when we start the program, and also that after it ends, we might want to go back and start it again at different times. And we might want to change the parameters of that animation for different repetitions. So the first thing that I usually start with is we could control how when the animation starts, like specifically. So the way to do that is so in Bonsai, the reason why this starts right away when I hit start is that Bonsai will start automatically when you run the program. It will start all these sequences. So these are all sequences of okay, create the window, read the positions from the mouse, and also the sequence of listen to the render frames and update whatever objects. So you can control in Bonsai when the sequences are started instead of by default when you press them that they just start. So you can control when they exactly start. The key operator to do that is this one called subscribe when. So the action of starting a sequence is called subscribing to the sequence. And by default, all of them get subscribed at the same time, but you can control exactly when they are subscribed. And you could say things like, for example, okay, I wanted to start the sequence only when I press a key. So if I do that, now there is nothing in the window because the sequence has not started yet. And what will happen now is if I press the key, the sequence will start at that moment, and then it'll play through the animation until the end. Yeah. Now, what we could do then is so right now we control the start now, but we would like to know when the animation has finished playing, so that we can kind of take full control over the whole sequence. So how do we define that? So in this case, there's two options. So one is because this circle is just being drawn forever, and the only thing that is controlling it is this animation, these two ones that for now they both have the same duration. So they kind of happen to match, but they didn't have to. We could have one that we could say that the looming takes longer than, or the other way around. You could say that the location takes longer than the looming. So you could have something that when I start it looms until the middle and then continues. So there's no reason why these need to be the same time. So in a way, the how long the stimulus is presented depends on what we consider that is kind of like our main timeline. What we could do here is so you can say the same way that you have subscribe when, you have a way to stop sequences. And I'm going to start with that, and then we can see how we can link all these together. So the way you stop them is, so the sequence is subscribed to, and there's values coming through. That is essentially the updates of the object that gets drawn. We can also control, we can stop that sequence by saying, I want to take until. So this take until operator essentially, when the event happens now, which can be another key. Now we can separate the two keys. I'm going to have different keys for it. So let's say this one is space, and this one is A, just for now, for the sake of argument demonstration. And so now what will happen is I have my space bar will play the animation, and then I need my A key to kind of, when I press it, it will remove the stimulus. Now here I can replace this by whatever I want. So I could replace this by a timer, for example. By the way, a slight parenthesis to say that in the if you type timer, you will see these two timers, reactive and shaders. Shaders is actually usually more interesting for controlling the timing of visual stimulus because it's tied to the refresh rate of the screen. So it gets updated in lock with the update of the window timing. Whereas the timer reactive, the default timer, is locked to the operating system timer, which both are useful for different things, but in general for timing visual stimuli, it's very, most likely you want the timer of the shaders. Anyway, that was just a parenthesis. So what I will put, so I put this shaders timer, and I'm going to put a time here. So in this case, I know that my animations are, they last for 1 second. So I'm going to put 1 second here as well for the stimulus in this case. And now what will happen is I have my stimulus that will start when I hit space and will last for 1 second and then will disappear. Okay, and then that's it. So it doesn't repeat anymore. Now, what we might want is just have many repetitions of this. And for that, you just need to, after the sequence that you created here, you place a repeat node. So the repeat node will essentially repeat the whole process. So essentially, what will this repeat? So it will wait for me to press the key, okay, and then draw the circle for 1 second until the timer fires. And then after that sequence is completed, the repeat will just restart the process again. So now it again waits for me to press the key and then waits for 1 second to draw the stimulus and then it goes away. So now if I just do that, I now have a space bar. It runs until the end. If I do it again, and so now I have like this repeating kind of process that is just going. And it's interesting that, for example, depending on where the repeat, this is one of the powerful things to think about in Bonsai, that these operators are quite general. They are not tied to any particular stimulus or sequence. So depending on where I put repeat, I can even have different effects. So for example, if I move the repeat over here, okay, so essentially what I did is I put the repeat in the middle. What is happening now? So now I'm still waiting for the key to start. Sorry, I think, Carl, I think you're trying to say something and then you're muted. I just noticed. Can you unmute?
Sorry,
Yes.
sorry. I'm trying to deal with something else. I'm listening along.
No worries, no worries. Sorry.
Sorry, multitasking. My apologies.
No worries, no worries.
Yeah.
We were doing the same thing. No worries. Okay. Yeah. So basically, so if you put the repeat in the middle, then what will happen? Does anyone want to try and guess? So essentially what will happen is, so we are waiting for the key to start, and then we start this sequence over here that will go for 1 second, and then we'll stop and it will be repeated, right? So now what happens is I click the space bar, and now the stimulus is just going by itself. So without me having to press the key, right? Because now the repetition is not, I'm not repeating the subscribe when, I'm not repeating the initial key down. So yeah, depending on where, so there's a lot of flexibility in kind of understanding these operators like subscribe when, take until, and repeat, as they give you a lot of like flexible control. You could do the other way around. You could just as well do, put this, sorry, subscribe when, you could, to rearrange, but I could also reverse it. I could say, or actually, I guess the best way would be I could, wait. I could, wait for the key press and subscribe on the timer, right? And it would kind of create other conditions. Okay. Anyway, so now how how would we change the parameters of this node? So for now, we know that the starting position, let's say, or the parameters. So we have these different parameters of how big the circle will become and so on, that right now are fixed. And we might want to change them, like from trial to trial. And so what we can do is we can control how these parameters are initialized by continuing to add more things before. So one thing that is also built into Bonsai is you can have random number generations. So that's also built into the numerics package. You can create a random number generator, and you can add a seed to it if you want it to be deterministic. But you can also leave it like that, and it will just generate random numbers based on your current computer clock. And then what you can do with this random number generator is you can configure it to sample numbers that you can use for setting other values, but you can generate them according to a random distribution. So again, we go back to this numerics package. If you type distributions here, then you will have listed like all of the available distributions that are in Bonsai to generate these random numbers. So you could say, for example, so you can just start with a continuous uniform distribution, for example, and we could say I want let's say the maximum, the end size of the circle will now be dictated by this a distribution that, let's say, goes from 0.3 to 1.5. So now the circle can have any of these interval of values in a continuous fashion. And now what we can do, so this creates the distribution, but then you need to sample from the distribution. That's also an operation. And the reason being that you can define the distribution, then reuse it many times. So if you use, you need to use a sample node to actually then get the value from the distribution. And then once you have that value, you can connect it to one of the parameters, let's say the end of the diameter animation. So the range end will now be sampled from this random distribution. Okay, so now that we have this, we can repeat the sequence again. And now, as I press the key, the circle will come out at the end with different sizes, depending on the number that is being sampled. We can actually see what number is that is being sampled over here. So it's going to be a random number between the range that I specified. Yeah.
Can you set a seed for this so it's always?
Yes. So that's what I was mentioning this at the beginning. So in the create random, when you create a random number generator, you can write the seed here. Yeah. So you can, if you have a fixed seed, then the sequence will be periodic. By the way, that's a very good point, because if you want to make sure that the seed doesn't start over from the beginning, because if you start the whole sequence, as I was kind of explaining here, and if you do set the seed, it will repeat the entire process, including the creation of the random number generator. So if you want to make sure that the seed goes through the entire sequence, you want to decouple this, in this case, from the entire sequence. So that's a very good question. How do you do that? So you could take the random generator, and you create in Bonsai, you can create variables. As in other programming languages, you can make assignments to named variables that then you can store values in them, and then you can read them elsewhere. So what we want to do is create the random number generator at the beginning with a fixed seed, and then read from the same random number generator every time we want to sample a new number. So how do we do that? So in Bonsai, variables are called subjects. So that's there's different kinds of subjects. The reason why are they not called variables? Because they do in a normal programming language, a variable is just a memory location that you write to and you store a value in them. In Bonsai, the variables can store many values, so they can store entire sequences, and depending on the behavior, they can do different things. You can replace sequences, you can just store the last value, you can just share the latest value, and so on. To store just a single value, when you have these operators just give you a value, they create something and then they stop, you can use this async subject, which I'm going to use now to just store the value that is created by random, and I'm going to call it random. So that will store the generator, and then what I will do is I will disconnect it from the sequence, and now what I will do is I will make sure to use. So now this variable is created outside of the loop of the trials, and now I want to use the value of that variable that I created in the rest of in my main program. So once you declare these variables, you can access them through the toolbox. So they will show up in you can type them by name, can find them by name, or you can also go here on the toolbox on the subject category. It will list the variables you have created. So I can put the random over there and now connect it to my distribution. And now the distribution is defined over this random generator, but now the generator itself is not recreated every time. So now we can put the seed in there. Let's put a fixed seed. And then once we do that, the sequence should be reproducible. So now I'm going to take like a few values. So let's say has this shape, so 1.1, 0.4 something, and then goes up back up. And now if I start it over again, it should give me the same. Yeah, it gives me kind of the same repeated sequence. Yeah, and then we can go on. Yeah, so that was a very good question about how to create these variables in Bonsai. You do it like that. You can use the same pattern for any other variable that you might want to store, either globally or locally. There's also strategies to do that. So now we are randomizing the parameters of the trials like that. I guess we are kind of covering a bit. So both the looming and the sweeping. So we're moving. Yeah.
Maybe we can pause here on this framework and cover the 3D version of doing it.
Yes.
Like where you have like a sphere moving towards you.
Yeah.
I think we've covered quite a few details here.
Yeah, exactly.
Can you save this as a...
Yeah, I'm going to save this as live coding. So let's save this as live coding, I guess loom sweep, something like that. Kind of moves a bit, or just loom. And then, now I'm going to loom with the sphere. Okay, so now let's look at, so essentially now what we can change here is not much, in the sense that we still want to just move so now instead of, the parameters can even be the same, but now what we want to do is just, instead of doing it with a circle that changes the diameter, we want to do it with a sphere in 3D that changes its position. So what we can do here is we can now replace the normalized view. We can replace with the perspective view, or even an orthographic view if we don't want perspective. So that's we can do either. But let's start with the perspective, just so we can. That'll also be interesting. And now we need to add a primitive that understands that perspective view, so we can draw a model. And what I'm going to do is actually do a couple of things. I'm going to export. I have it already done, but I think it's also useful to show this. I'm going to use Blender to export a model. because I think in that way we also cover how you export or how you can import your own models from other softwares. And what I'm going to do is just use Blender to create a very basic sphere. So you can add here mesh, mesh. We can add a UV sphere. Make it smooth shading, and yeah. So you can just export it. This would be, if you have other softwares to do this, you can. Bonsai now supports a lot of different formats. But for now, let me just export this one as a sphere.
I guess another thing that we've done before was just download pre-existing object files of different
Yes.
3D shapes and then put them into Bonsai.
Yeah, we have, there is one object that comes built in 3D that is generally very useful, which is the plane that comes built in. We can in the future include others if they prove to be very useful, but otherwise in general for 3D, there's so many different objects you might want that you can just export them from anywhere or find them online. These OBJ files are quite common. In one thing that I think now is even more robust in the new version, I think it will try to do this for you automatically. But one habit that I gained is that some of these softwares, they don't export your object as triangles. This is a totally different topic, but it's in the kind of lower level drawing pipeline. Ultimately, all the objects are broken down into triangles that you want to use for drawing the surface of the objects. So that triangulate faces was necessary before. I just keep doing it as a kind of a habit. But okay, so now what we need to do is we need to load the objects that we've created. And now I can show you how you would do that from after the BoneVision resources. You can add more resources, as I mentioned before. So now I'm going to add these this mesh resources, okay? And I'm going to go to the meshes. You can go here for the collection, or you can just double click on the node. And now what I can do is I can just let me go to the folder where we are. So you can just drag the object into there. So if you have more objects, so I have my object here, I drag it over there, I have a sphere. And then I can, in my model, I can pick now the model. I have the built-in plane, as I mentioned, and now I have a sphere, and I will add the sphere in there. Now, in the properties of this node, the names are slightly different. So here we talk about a translation X, translation X, translation Y. And instead of a diameter now, what I'm going to do is move the translation in Z, for example. And now, one important thing, of course, in 3D, in perspective, you have to say where you're, how you are drawing the objects relative to which point. So you have to define kind of your viewpoint into the scene. So you do that in the parameters of the perspective view. So you can say this kind of follows the OpenGL lookat format. So you say, what is the position of your camera? So I'm going to say that it's at, let's say 0, 0, 1. Looking at 0, 0, -1, and what is the direction of my up vector is, yeah, the y-axis is pointing up. And you can specify the field of view that'll kind of give you the zoom or the field of view of the camera lens.
Hello?
Yeah.
Can this be dynamic?
Yes. Yeah. All of these properties, as before, you can externalize them and control them automatically. So we can later animate the eye. So we can discuss also later. For now, I'm going to move the sphere, but you could also move the camera, yeah, and have the scene.
I guess one other thing is that this is the scene drawing aspect of it, but actually the putting it onto the display is another thing that can be done independently in addition. So right now we're just looking at everything that is being rendered in the scene. If we were running an experiment on an experimental rig, we would specify that there is a display that covers this aspect of the visual angle. So it will only show it in that part. So that's another additional thing that can be done in Make as well.
Yeah. And right now I am assuming this kind of there's a single perspective onto the scene, but as Aman is mentioning, when we are actually doing this kind of projection of the scene into multiple displays or into a bigger display, often what we do is we render a 360-degree view of the entire environment, which you could also do it here. But for now, let's just keep it to this for simplicity. But yeah, all these things are possible. So let me see if, okay, so now we have a big sphere that probably we're not far away enough because it depends, it will depend in a way also on our field of view. But for now, for simplicity, I'm going to just position myself away, more farther away. This is not, we also have the, I'll tell you how to can tweak the parameters of the shading so we don't have like the effect of the light. So now we are kind of seeing there's a light source that is also defined in the perspective view, and our sphere is kind of being influenced by the light, which is also another very common property of 3D scenes. To show 3D, you usually use light cues to illuminate. You can get rid of them essentially by controlling how the material of the object responds to the light. So that component will be the diffuse and the specular component of the material. If you get rid of them, then we will get rid of the light reflection. Then we can put here more kind of, or actually you can even put it 111 to have like a white. So essentially, then we lose all the light cues. So now we actually have, if we make it, so it looks more as our circle, simply because we've eliminated how the light is falling off the surface of the sphere. So it's looking more like but now you can actually see the deformation that is happening here is coming from the perspective camera, because now we have a perspective camera, it's not an orthographic camera. So we're getting that extra cue that the projection onto different parts of the image fall in different kind of angles according to the, of course, you could have the same effect by drawing into, as Aman was saying, by controlling how the display, where the display is relative to the, because we can do this in two ways. I guess in this way, I'm doing the way that is typically done in a video game, or you define a 3D camera with a certain perspective. But usually what we tend to do also in BonVision is, as Aman was saying, defining where the screen is relative to the subject. Yeah. But in any case, before we go there, I just wanted to pause a bit and say that essentially we haven't changed much. I mean, this is one thing that I like about BonVision is that we didn't change much we only changed a very specific portion of our workflow, which was the drawing of the model itself and the perspective camera, but and of course the property mapping. So this portion over here. But what we could do is we could have separated that from the, so but everything else stayed the same. So we changed quite a lot of conceptually we changed quite a lot in the sense that now we're using 3D versus 2D. But in terms of the logic of the program, like the distribution of the values for the diameter, or what's the diameter before, and the positions, they're all the same. So there wasn't like a massive change to our program just because we changed from 2D to 3D. It's basically the same kind of logic applies to everything. Yeah, and we still have our little reproducible seed generator. Okay, so I'm going to pause here, and maybe is there any questions, or which direction should we go next in the time that is left? I reckon.
So how do you log the information about the stimulus? Or,
Yeah.
for example, the parameters over time of the stimulus?
Yes, exactly. Yeah, good question. So there are different ways to do that, and of course, there's different ways of depending on also on how which parameters you want to log. So let's say, for example, to begin with, let's say that I wanted to log just to have just one value for now. Let's say I wanted to log just the random parameter. So let's say that every trial I have a parameter. So let's say I just want to log that to begin with. So and let's say we want to log the random number, and we also want to log in which frame we want so we want to know which frame the trial started with and what random number was sampled from to parameterize that trial. So we wanted to do that. So in general, to log data aligned to the frames was a very important concern we had with BonVision, and we created so there in Bonsai there's many ways to log data. We could just put here a CSV writer, as those of you who've used Bonsai for other things would know, and you would write the parameter to a file, and that would be fine. But in our case, we have this additional desire that we want to log things relative to the frame, like to the timing of the screen. And to do that, we added this this specific logger that comes with BonVision. There is this frame event logger.
Actually, Gonzalo, can you show the BonVision.logger to
BonVision.logger? You mean in the BonVision logging here?
Yeah. So there's three logger. Yeah, there's three things.
Yeah, there's three. Yes, there's three. So you can log. There's loggers for events in general, and then you have loggers for frame events that basically tell you, yeah, when you're logging, and then you can use log event, which is a primitive. I'll give an example very quickly that essentially lets you log events relative to these loggers. The one that I'm going to use now is this frame event logger, because it basically gives you this kind of functionality I was saying, that it kind of records together with your events the information about the timing of the frame of when the data was was produced. So what I'm going to do now, and there's also different clocks you can use even for the frame event logger. You can use a timing of when events are drawn, or when frames are drawn, or you can use a timing of when the frames are updated, when you update the states of things. And those can be useful for different things. We can discuss them later, but for now I want to log my events relative to when the frames are drawn, when they're actually displayed on the screen. So to do that, I need render frame again, and I'm going to place it here again, and I'm going to add the logger after the render frame. And the reason for that is, as I was saying, because there's different events you can use for determining what clock is meaningful to you. In this case, I'm saying I'm interested in when frames are displayed, presented, and not necessarily when they are just updated their state. So you create a logger like this. You can give it a name. By default, it's called events, but we can say this can be, I'm going to call it parameters now. And we can also add, this is kind of behaves like our CSV writer for those who know Bonsai. So you can also add suffix like timestamp. So by the way, for now, we are actually changing this soon, because we realize sometimes you want to have the name of the file separated from the name of the variable that is going to store the parameters. But for now, in the current version, the name you add here will be the name of the file. So parameters will be, if I type the name parameters, it will record a file called parameters.csv with all of the events that are logged. Okay, so I create that logger that is going to log things relative to the frames. And now, whenever I want to log data, I can just put a log event. So for example, now let's say I want to log when the random value, which is going to be the moment of the first frame, of when the stimulus is created, I want to log that value that is sampled from the distribution. So I'm going to put a log event here. And now, let's see what it's complaining about. So by default, I set the name of the logger that has these events, but I changed the name. So now it's called parameters. So you have to add it to that. You have to put in here the correct name. So now it's happy with that. And I guess it will just save the double. In the log event, you can also add formatters. I'm not going to talk much about them today, but you could add like things like you could say like, or I can add distribution curly bracket 0, or this could be param 1, something like that. And essentially, what will happen is you can format the text that is written in the file however you want. So you could put that here if we wanted, or just P like that. Okay. Okay, so if I do that and I run this again, I'm going to run a couple of trials. Say, say 4 trials. And now if I stop it again. So now if I look in here, I have my parameters file that has been created. Okay, and now if I open it, it's going to show me essentially so which frame the event that was logged was when it happened. So essentially it was produced. So this value was produced on frame 66. The timestamp, this will be the timestamp in seconds from the beginning. So frame 0 will be timestamp 0, and then we go from there in seconds. So you can know the time. You can know the timing both in frames or in seconds. And then this is the value that is created. So I pressed the 4 times at these different intervals, and they are logged here. And there's the P that I put in there. This was the one that but I can repeat it again just normally, or I can just delete it. You don't even need to put a format. Yeah. And now, so we create it again. Now it's going to be a bit faster, I guess. And if I look at, there's a new file. And now I should have yeah, little faster values and the same numbers coming out because it's a fixed seed. So
we should wrap up pretty soon,
yep.
But I think it'd be quite interesting since we're on logging. Maybe it'd be nice to also show like how to log every frame, the time of every frame that was presented.
Yes. That is that's a very good point, and that's a very easy thing to do. And we should also do it. So first of all, is we can, as I was mentioning, we can create multiple loggers. So let's say that I wanted, I'll create another logger just in sequence. So and this one I'll call it frames. Okay. And then what you can do is you can log the event of the frame itself. So you can say, so this is already when a frame is being drawn. So I create these 2 loggers that are being updated, and then I'm going to log that event right away, which I have to pick. Again, I have to pick it from the list of the loggers that exists. I'm going to say I want to log this to the frames. And now what I'm doing is essentially logging the event of the frame itself on the logger of the frames. So if I run this now, so I'm going to do the same thing. And now I have the logger of the parameters of the file, but I also have these frames. I didn't add a timestamp, that's why I didn't forgot to add the timestamp, but it's there. And now there's much more data in there, and essentially, no idea what's going to come up. Yeah, I didn't put any meaningful data in here, but here is just logging the frame sequence itself. So essentially, it's going through from frame 0, which I guess already comes from 0.016 actually. Yeah, it's already the end. The reference is the end of the frame interval rather than the beginning. But yeah, so then you go 0, 1, 2, 3, 4, 5. And it's going to show you the timing in the in the operating system time of when the frame when that frame was happening. So you can have an idea of the distribution. So if we, for example, if we do let's say something like this. So we could see the progression. Yeah. So for example, here, so this is something that is quite interesting. And we can log this in many different ways. So sometimes what can happen is if you get glitches in the let's say delays in the presentation of frames. So for example, if there's frame drops, or if there's jitter in the operating system that is involved in the generation of the frames, the underlying OpenGL engine will compensate for those frames by generating the successive frames faster. So what probably happened here, if you can see, is that we actually had.
In this case, it just dropped a frame.
I think it just dropped the frame. Yeah, because we have like we had the extra. The easiest way to notice frame drops is actually not to log the. So if you log just the frame display, the frames that were presented, you will see things like this, where now we could plot them. So we could plot this kind of interval, and we could see, so those were our frame drops. There was also another big one at the end, because I'm probably also running Zoom and many things that are happening in my computer right now with the graphics card. But you can have a look at the timing of the frames here. If you want to look at the compensation of the timing, you can also log the I guess what I was talking about the compensation of the animation timeline, I guess, is the last topic I want to discuss. To see this, we would have to log the update frame. So what is happening when there's a dropped frame like this? One question that we were concerned from the beginning is, how will this affect the timing of my animations or the duration of my stimulus? So let's say that I'm drawing a sweep or a certain sequence for, let's say, 2 seconds. And the question is, if I drop frames, is the duration of that going to be disrupted? And it shouldn't, because essentially what is happening is as the animation is progressing through the drawing, if there's a drop frame that is detected, the time that elapsed in that dropped frame is going to be compensated for in extra update calls. So essentially, the animation of the sequence is going to take actually the same time, because the extra missing time is going to be still animated in that sense. So if we were to plot the total duration of the stimulus, it should still, I guess in this case it's hard to see because we're just drawing the progression of all the frames from the beginning to end. But if we were to draw the duration of all the duration of the animations, of the individual animations, if it's 1 second, it should always be 1 second still. Yeah.
We should wrap up.
Yeah. I think you're breaking off, man. Oops. Oh, you broke. You're back.
I was just saying, in case you hear me now.
Yeah, you can hear it.
In case you hear me now, I was just saying we need to wrap up. And if there's any other questions.
Yeah.
I'm going to stop recording then if there's
Yeah, sounds good. Sounds good.